Let us now do the proof of the second property, which is sine inverse minus x equal to minus sine inverse x. Now clearly here the restriction on x is that it should belong to minus 1 1, which is the domain of sine inverse. Now let sine inverse minus x equal to y, call it equation number 1. This gives us minus x equal to sine y, which gives us x equal to minus sine y. Now to be able to take the sign to this side, we don't need a minus sign outside. We have to absorb this minus sign inside. And so what we can do is we can write it as sine of minus y. Now take this sign to this side and we get sine inverse x is equal to minus y. This gives us minus sine inverse x is equal to y, call it equation number 2. So from 1 and 2 we get sine inverse minus x is equal to minus sine inverse x. Similarly, you can do the proof for tan inverse x and cosec inverse x. Now, let's consider one of the inverse trigonometric functions in the second group. So that is, let's take cos inverse minus x. The property says it is pi minus cos inverse x. Now again, for what values of x will this result be valid? For the domain of the function cos inverse, which is x should belong to minus 1 to 1. Now let's start. Let cos inverse minus x equal to y, call it equation number 1. This gives us minus x equal to cos of y, which gives us x is equal to minus cos y. Now we need to absorb this minus sign in this cos to be able to proceed further. And how do we do that? Cos of pi minus y. Cos is negative in the second quadrant. And now you can write it as cos inverse x is equal to pi minus y, which gives us y is equal to pi minus cos inverse x, call it 2. And so this gives us from 1 and 2 we get cos inverse minus x is equal to pi minus cos inverse x. Similarly, we have the other two results of this group, that is cot inverse minus x is pi minus cot inverse x, and sec inverse minus x is equal to pi minus sec inverse x. Now we consider the next set of results, which is sine inverse x plus cos inverse x is equal to pi by 2. Now this is valid for x belonging to minus 1 to plus 1. Next is, now here, since this is the domain for both sine inverse and cos inverse, the next result is tan inverse x plus cot inverse x is equal to pi by 2. For this, x is equal should belong to R, which happens to be the domain of tan inverse x and cot inverse x. And the third result is cosec inverse x plus sec inverse x is equal to pi by 2, for which mod of x should be greater than or equal to 1, which happens to be the domain of cosec inverse and sec inverse. Now let's quickly do the proof of these results before proceeding further. Now let's start. Let sine inverse x equal to y. This gives us x is equal to sine y, which can also be written as equal to cos of pi by 2 minus 1. This, when taken here, gives us cos inverse x is equal to pi by 2 minus y. Substituting this, the value of y from here to here, we get cos inverse x is equal to pi by 2 minus sine inverse x, which gives us sine inverse x plus cos inverse x is equal to pi by 2. Similarly, we can do the remaining two results, that is tan inverse x we assume as y, which gives us x is equal to tan y, which can be written as cot of pi by 2 minus y, which gives us from here cot inverse x is equal to pi by 2 minus y. Substituting the value of y from here to here, this gives us pi by 2 minus tan inverse x. So we get tan inverse x plus cot inverse x is equal to pi by 2. Likewise, we can write sec inverse x plus cosec inverse x is equal to pi by 2. Thank you.